Hey guys, Mr. C here, and I'm going to show you an application of composition functions. Really cool application problem come our way, and it's because it deals with shopping, but specifically shopping using two different types of deals and how the order in which you apply the deals does actually make a difference. So a pretty cool thing that you can actually try out at home. So the problem states that the manufacturer of a computer is offering two different discounts on last year's model computer. The first discount is a $200 rebate, and the second discount is 20% off the regular price X. So for parts A and B, we're just going to come up with functions that represent each of these discounts respectively. And then for part C, we're going to start blending them, but we're going to blend the discounts via composition. And you're going to see that the order in which we apply the discounts actually does make a big difference for the consumer. So a pretty cool thing to see. So let's go ahead and get started. For part A, it says write a function f of x that represents the sale price if only the rebate is applied. So let's go ahead and start with function notation, f of x. And basically, the way this works, the way most rebates work, is that you're going to get some money back, which the net effect is that you're taking the regular price and just chopping off, in this case, $200. So let's go ahead and write x to represent the regular price. And once the rebate is applied, the net effect is that you're starting off with the regular price and then reducing it by $200. And that's basically all there is to part A. For part B, it says write a function g of x that represents the sale price if only the 20% discount is applied. So to write this function, you kind of want to think of it in a different way. If you're taking 20% off the regular price, then the net effect is that you're paying 80% of the original price or the regular price. So basically, g of x is going to look like this, 0.8x. Alright, so the 0.8 represents paying only 80% of the regular price. And that's kind of the net effect of taking 20% off the regular price. So for part C, what we're going to do is find the composition of these two functions in the two different ways that we can form the composition. So the first part says find f of g of x, and then g of f of x. So here we're reversing the order of composition, and as we've seen, in most cases, when you reverse the order of composition, you don't necessarily get the same function. So we're going to form those, and then I'm going to talk about what each of these functions represents. And then we'll try to investigate, which combination of discounts represents the better deal for the consumer. So let's go ahead and get started with the first part, f of g of x. So as we discussed, this notation means that you're going to take the function g of x and plug it into the function f of x. So we're going to take the 0.8x and stuff it right inside here so that it becomes 0.8x minus 200. But let me go ahead and flesh out one more step. So f of g of x really means f of 0.8x. And so anywhere we see x in the function f of x, we'll just replace it with 0.8x. So going back up here, and as I already stated, this is going to turn into 0.8x minus 200. And that's what the composition f of g of x looks like. Now we're going to go ahead and reverse the order. So we'll do this composition this time, g of f of x. And I'll flesh out what this means more specifically, g of x minus 200. So in a very similar spirit, anywhere we see x in g of x, right here is where we see it, we're going to replace that with the expression x minus 200. So this will look like 0.8. Instead of x, it's now going to be x minus 200. And I'm actually going to leave it like that. Of course, you could take the liberty of distributing the 0.8 to both of these. But there's actually a reason why I'm going to leave it in this format versus a more simplified one. And that's actually to talk about the first question here in part C, what does each of these functions represent? So let's go ahead and look at the very first composition we formed, f of g of x. We wound up getting 0.8x minus 200. And if you think about how this function works, picking, say, like some sort of random value of x, the first thing we would have to do in order to come up with the output is multiply it by 0.8 and then subtract 200. So what order, I suppose, would be the question, what order of discounts are we applying first? Are we taking the $200 off first, or are we applying the 20% off discount first? And basically the answer to that is we're applying the discount first, the 20% off discount, and then taking off the $200. All right, so this function represents applying the 20% discount first and then the rebate. So I'll make a little note there. So here's the meaning of the first composition function. The 20% discount is applied first. Then the $200 rebate. All right. So you can probably tell what the second composition function represents, or what the meaning of that one is. So if you look at the format of the answer for g of f of x, if you were to plug some random value of x in, the first thing you would do via order of operations is subtract off the $200. So remember, in order of operations, we have to do whatever's in parentheses first. So for some chosen random value of x, what we'd have to do is subtract off 200 and then multiply it by 0.8. So what this ultimately means is we'd be applying the $200 rebate first and then the 20% discount. So let's go ahead and write something to that effect. So I'll say the $200 rebate is applied first. Then the 20% off. All right, so you can see that reversing the order of composition of these functions does produce two different looking functions, but in the application setting or nature of this problem, what it means is that we're forming two different combinations of these discounts or deals, and the orders are different. So for example, and to kind of summarize, doing f of g of x wound up giving us 0.8x minus 200, but the actual meaning of that is that the 20% off discount is applied first and then the $200 rebate. Whereas if we reverse the order of composition, we do the $200 rebate first and then the 20% off. So then the big money question, all pun intended there of course, is which is the better deal for the consumer? Well, to get an idea of which of these is a better deal for the consumer, I would recommend maybe choosing some sort of specific value of x that you probably want it to be larger than 200. So let's go ahead and maybe work out an example here with a random value of x. Let's say let x equal 1,000. All right, so the 1,000 would designate a computer that's its regular price is $1,000. If we wanted to look at the values of both composition functions when x is 1,000, you're actually going to see that one combination works out to be better for the consumer. So let's go ahead and maybe write f of g of 1,000, and basically we'll be utilizing the first composition function that we formed. All right, so you can just jump straight to this expression right here, 0.8x minus 200, and just use x as 1,000, so 0.8 times 1,000 minus 200. This actually works out to be 600. All right, because 0.8 times 1,000 is 800, minus 200 is obviously 600. All right, so that's the price you would be paying after that combination of discounts in that specific order for a computer that's originally $1,000. Now if you do g of f of 1000, this is the other composition function, or the reversed ordered, you'd have 0.8 times 1000 minus 200. All right, and that's coming from this result right here. So again, order of operation kicks in. You want to do 1000 minus 200, and then multiply the result by 0.8. All right, so that's going to be 0.8 times 800. And what would this work out to be? Should come out to be 640. All right, so both of these outputs would be what the consumer is paying. So between the 600 and 640, which result would be better for the consumer, paying $600 or 640? All right, so I'll leave that question up to you, and your answer to that will ultimately give way to the final answer of part C, which combination of discounts represents, should say, the better deal for the consumer. All right, and so that's how we take care of the very last problem, the section 6.1 note packets. Again, like I said, a really cool application of composition functions. Feel free to let me know if you have any questions. Otherwise, I really appreciate you watching, and have a great day.